Okay, Algebra 2, here we are in 13.6. Let's see if we can talk about some of these problems. I did mention we were going to skip example 1 because I feel like our talk kind of covered a lot of the content there, and let's see what's going on with example 2. So in example 2, we're looking for the cosine of 675. Whenever you see exact value, do not pull out a calculator and look for the value your text or the test or whatever thing you're filling out is expecting you to come out with an answer that is not decimal, okay? That is not some kind of irrational number. Well, it will be irrational, but it's like square root, or it may be irrational. Okay, I'm talking too much. Let's do the problem. So we know that this is 0, this is 90, this over here is 180 and 270 and back to 360 again. And then so we know if we go to 675, if this is our initial rate, we would have gone around one time 360, and then we would need to go around further to get to 675. So the first thing I want to do is figure out the difference between 360 and 675, and I see that's 315. So that means if I go around 360 and then go around 315, that's going to represent this angle of 675. So let's do that one, and boom. So we end up here, 315, I'm going to just say is here after, it's going to be somewhere between here and here. So what is the reference angle is the question that we're talking about, because as soon as we get the reference angle, we've got this. So the reference angle from 315 degrees, I'm saying 315, you guys know I mean 675, but I'm talking about that last round. So 315 to make this 360 would be 45, right? So this is a 45-degree angle that we're talking about. The reference angle for 675 is a 45-degree angle. And so now this 45-degree angle, what we have to remember is the cosine of 45 degrees. If we go back to that chart, we can see that the cosine of 45 degrees is going to be square root 2 over 2. So I know that the cosine of 675 is going to be the square root of 2 over 2. But wait, I need to consider the quadrant. Is it positive or negative? Well, we remember all students take calculus, or all of the functions, the sine function, the tangent function, and the cosine function represents what's positive in each quadrant. Since we know that the cosine function is the only thing positive in this quadrant, I know that this answer is good as it is. The answer is the square root of 2 over 2, and it's positive. Let's try the same idea for the sine of negative 5 pi over 6. We're dealing with radians, so we've got 0 radians here, pi over 2 here. Let me write it in black. Pi over 2, pi, 3 pi over 2, and then 2 pi, and we can continue on. Here we're dealing with negative 5 pi over 6. Now, I like to think about this. What was pi over 6 again? It was 30 degrees. So what we're doing is we're going 5 groups of 30 degrees in the negative direction. Of course, we could take 5 pi over 6 and just translate it directly into degrees if that's the way your mind works. It's just the way my mind works. But let's say we don't even do that. So let's say we just say, okay, this is 1 pi over 6, 2 pi over 6, 3 pi over 6. You guys with me? 4 pi over 6, and 5 pi over 6. This is me going in the negative direction here. You guys kind of feel that? And therefore 6 pi over 6 would be here, which would be pi. And so our reference angle would be pi over 6. This little angle that it takes to get back to the x-axis. Pi over 6 or 30 degrees. And so we go back to our chart. And here I can observe that the sine of pi over 6 is 1/2. I'm talking about the sine of pi over 6 is 1/2. So I'm going to use that in my answer over here. So I know that this value is going to be 1/2, right? But remember, what quadrant am I in? Remember it, all students take calculus. I didn't mean to write that, y'all. I meant to write all sine, tangent, and cosine. So we know that the only thing that's positive in this third quadrant would be the tangent. Therefore, sine is not positive. So the answer to this would be negative 1/2. So the sine of negative 5 pi over 6 will be negative 1/2. Here's our last example. So as promised, here's our final example for this section. And so this is kind of like the video we saw in the first part of this in terms of an object on a wheel going around. So as you ride a Ferris wheel, the height that you are above the ground varies periodically as a function of time. Consider the height of the center of the wheel to be the starting point, and a particular wheel has a diameter of 38 feet and travels at a rate of 4 revolutions per minute. So a full revolution is basically ending up where you start, and you will do that 4 times in 1 minute. Identify the period of the function. So the period is the time it takes for one revolution to happen. So if the period is the time it takes for one complete revolution, and we know 4 revolutions happen in 1 minute, it's pretty simple to see that in 1/4 of a minute, or in 15 seconds, we would have one complete revolution. So 15 seconds is the period. This next question will help us visualize it the way I talked about the period in the last video when we kind of chunked a piece of the picture. We're going to make a graph in which the horizontal axis is the time t in seconds, and the vertical axis represents the height in feet in relation to the starting point. For the convenience and for the sake of time, I'm going to show you this graph so you kind of have an idea of what's happening as opposed to us figuring it out right now. So if you were to be seated on, let's say, this blue seat, then you would begin at, in a sense, 0. Remember, the diameter was 38. So your height would oscillate between 38, plus or minus 19 feet, right? If you're starting in the center. So you get the full spectrum of the 38 feet, if that makes sense. So if you're starting in the middle, you go up, you come down, you go up, around, you're back to your starting level, but not the starting position. And then you go back up again, so you get back to your starting position. That took 15 minutes. And then you do it again. And then you do it again, and then you do it again. And so you can see the 4 revolutions, right, in a minute. And then what I want you to also notice is, if I were to cut this picture right here, and in a sense, I can photocopy this over and over again and complete the actual function. So this is the smallest portion. So the period, in a sense, is the smallest portion of your graph that you can cut in order to make a continued graph in the same way. And I know this is a lot of information, guys. Please, please, keep in mind that it will all come together. The more work you do, it will make sense. Please hold your questions for me. Ask them when you need to, send emails, whatever we need to do in order to make it clear and palatable for you. Listen, I look forward to seeing you guys soon. Please, please take care. Bye-bye.